morning, ladies and gentlemen, and welcome to our chemistry show. The show was prepared for you by the students of Doctrina Podještědské gymnázium and Gymnázium Park Mládeže in Košice as a part of the Erasmus Plus program called Explore Science, Experience Culture. Allow me to introduce also the teachers involved, who are Alena Šáfrová, Zuzana Tomečková, and Lenka Šimková. My name is Dalibor Hanzal, and these are our students.
All right. Hello there.
First mistake. Hello there. My name is Patrick, and I'm sure you're all very excited to see our chemistry show. However, we are very, very nervous. I mean, my hands are shaking, my voice is cracking. So I prepared this ritual that you can do too. And so what I need is just your attention and our body, I guess. So the first thing we do is we stand up. Those who obviously can, sorry, Linda. You can do it seated, so please stand up, all of you. And I just want you to imagine, I don't think you have any nerves, but we do. So I just want you to imagine that you have, I don't know, what is it, whether it's anger, I don't know, your boyfriend dumped you, whatever. Okay. Just imagine the hate, the bad stuff in you, okay? And you just want to shake it out. Come on, shake it out. Use your legs, yeah, use your arms. You can sing too. And on the count of 3, please, just use the weird sound. Doesn't matter, like, just your inner demon, we don't want that, okay? We want it out, okay? So, okay, 1, 2, 3. I think that's it. Hopefully you'll enjoy it. I mean, it's great. It's absolutely stunning, and yeah, I guess that's it. So first, wait, who's it? Oh yeah. So ladies and gentlemen, these are your first performers. Yeah. So round of applause for them.
I was supposed to use helium, but I forgot, so never mind.
Hi, I'm Adam.
Well, I'm Maciej.
And welcome to our chemistry show. I won't waste any time, so let's start with our first experiment. As you can see, I trapped Aladdin in this bottle, but I suppose he is very thirsty, so let's pour him some magic liquid.
Well, I'd say it's just water, but...
Okay, so I guess he was thirsty, but let's also feed him, because I suppose he is hungry as well. Well, he was hungry.
Yeah, but you might call this an Aladdin, but let me show you what a real Aladdin looks like. I found this one at the bottom of the North Sea, so he must have been there for ages, so he's definitely thirsty and hungry as well, so let's get him something to drink, and maybe even something to eat. So, well, what you saw now was an oxidation reaction between potassium permanganate and hydrogen peroxide in neutral or slightly alkaline environment. In short, hydrogen peroxide acts as a reducing agent, and permanganate acts as an oxidizing agent. And during the reaction, oxygen gas is released, and brown NO2 pass participate appears. So yeah, well, that's all.
A teraz preklad do slovenčiny alebo do češtiny. Čo sa vlastne dialo, bola to redukčná reakcia, exotermická, ako ste mohli vidieť. A manganistán draselný sa redukoval na oxid manganičitý a na druhej strane sa oxidoval peroxid vodíka, ktorý sme priliali ako prvý. A zároveň sa formovala voda vo forme vodnej pary, ktorú ste mohli vidieť, ako sa vlastne zniesla nad nami. So that was our experiment. Let's invite another group. Sometimes this just happens.
Yeah, he was really big one, so maybe but didn't survive.
We have no idea how many jars we have already destroyed.
Okay, well, that was something.
Yeah.
Do you suppose that jars like that are expensive?
Yeah, they probably are.
Well, too bad. Anyway, I heard, I'm a chemist and I'm quite a wealthy one, as you can see. And many rich chemists usually carry around all of their money in their pockets of their lab coats, just like me. So,
But I'm a chemist as well, and I'm broke.
how so?
You know, every time I make an experiment, all the money I carry in my pockets just burns. And, well, okay. And, well, I'm left with nothing, see?
Oh man, that's too bad. That actually used to happen to me as well, a lot, but it doesn't anymore because I found a way how to outsmart fire.
Oh, really? And how exactly did you do that?
Just sit back and watch. Okay. I'm gonna take a regular bill, okay, as you can see. I'm going to put it inside of this. Drench it a bit. I'm gonna take it out, and you're gonna light it on fire.
Oh, wow, that's incredible. Why didn't it burn?
Well, that's a great question. Does anybody know why it didn't burn? Would anybody like to know why it didn't burn? Yes? Okay, well, what happened was that we prepared a 50% solution of ethanol, which is this, and we took a normal bill, we dunked it into it, and then we lit it on fire, as you can see. And what happened was that while the dollar bill itself didn't burn, the ethanol did. So ethanol is a liquid that is highly flammable, but water, which is also present in our solution, is not. It absorbs thermal energy, which means that the water acted as a protective layer for the bill, which is why it didn't burn down, and I'm rich.
Teraz vám to ešte rýchlo zhrniem v slovenčine. Takže pripravili sme si 50% roztok etanolu, v ktorom sme namočili našu bankovku. A keďže ten roztok obsahuje aj vodu, tak horel vlastne iba etanol a voda absorbovala tú termálnu energiu a vlastne správala sa ako taká ochranná vrstva pre našu bankovku, ktorá preto nezhorela.
To je vše. Now we welcome Patrick again with Alex.
Yeah, so thank you very much. Wonderful experiment. Ours is better though. Where are you? Oh, okay, I guess I'm gonna do this myself. So welcome to the fortune-telling cave. So the previous experiments were fine, yeah. They weren't anything special though. See, that's where we come in and we show you something very special. For that, we need one volunteer from the crowd. Anyone. All right. Right, come in. You can introduce yourself. What's your name? Oh yeah, round of applause for her. What's your name? Elishka. Okay, so we're in a fortune-telling cave, so we are the fortune tellers, obviously. And so what we'll do right now. Okay, so pick any metal cation here. This one, okay. Blue, you like blue, don't you? Yeah. All right, so I'll inject this or just put it in the flame and we'll see what happens. We also had music with it, but we don't have it, so just imagine there's this music, I don't know. All right. Oh, I see green. I see green. What does that mean? What do you think?
Green means nature, I think.
Nature. You're a nature girl, aren't you? No, but so it means nature, right? Something with animals.
Yes.
Yeah, I guess something with animals. Do you have a cat?
No.
Well, you'll have one soon. You'll have one very, very soon. Do you want to know whether it will be a boy or a girl?
Definitely.
Okay, so pick another one.
Okay, this one.
This one, okay. You can do it yourself if you want to.
Okay.
Just, yeah, do that. Try. Oh, red. I guess I have a feeling like red, like aggression, like testosterone, you know. I feel like it will be a boy. A boy, yeah. A boy cat. All right. Do you want to know if he'll have any other like friends that he could play with? Yeah. Okay. Pick two. You know, pick two. Just spray them and.
Okay. Like.
Yeah, it doesn't matter. You can just pick one and. Oh, it's more like orange-ish, isn't it?
Orangish red.
What does that mean? What do you think that means? Because, you know, we're not that good at it.
Maybe some fruit.
Fruit. He'll have like a friend, like a fruit friend, like a banana or orange. Yeah, I guess orange is orange. So, yeah. Okay, so he'll play with an orange. And what was the other color? Or what was the other? What's it called? Metal cation. Yeah, we don't even know the names. Ooh. Okay, that's not even like nature-wise. This is something else.
But it was definitely orange.
It was orange. It was definitely orange. I can even smell it. Can you smell it? Smell that.
Yeah.
I smell a child. I smell it. Come on. Smell it. Do it one more time. Come on. I don't know which one was it. Yeah. In 6 years, you have a child. Maybe expected, maybe not, but okay. Thank you very much. Round of applause for her.
And now back to chemistry. At
Yeah.
first, I will know the English explanation of this thing.
I'll try. Okay, so the way it works is when we put the methyl cation in the flame, basically the electron gets excited, right? Not like excited, woo, but like, you know chemistry better than I do, so, but it gets excited and basically it creates this big energy and therefore the flame turns different color. And different metal means different structure, so each flame is differently colored.
Ešte v skratke po slovensky, tak dochádza k tomu, že kation, ktorý sa dostane cez roztok do plameňa, sa dostane do excitovaného stavu, lenže tento stav je nestabilný a potom dochádza ku navráteniu do pôvodného stavu.
pričom je emisia energia, ktorú my vidíme v podobe farby. A pri každom kove je to iné, preto vidíme iné farby pri každom katione.
Right? That's it. Thank you very much. Next up are these two beautiful gentlemen. I forgot their names because I wasn't at the previous Erasmus. Yeah.
Hi,
My name is Marov.
and I'm Adam, as you already know. And we are doing casting for the best fire actor. As you can see, we have 4 glasses. Each glass contains gas. For example, can you guess which gas
I
is?
don't know, maybe we can ask the audience.
Yeah. Do you know which gas or what gas is in this bottle? Probably no. So let's start our experiment. Well, as you can see, in our first jar, it was just basic air. It is mixture of gases, 21% of oxygen, 78% of nitrogen, and it just continues to burn. Well, air is not flammable, so we can do another. Can you guess what gas was in this jar? No? Okay. So in this jar was oxygen, which is also not flammable gas. It just enables fire to burn, and it is essential for burning. Well, our third candidate didn't even perform. It just chokes the fire. So I think, do you know what gas it was? You there? Yeah, you were right. Can you guess what gas is it? Yeah, it was butane. It is highly flammable. It contains a lot of carbon, which can be oxidized by air, oxygen, and it burns. So that was our experiment.
No, takže prvý kandidát bol vzduch. A to je vlastne prirodzené prostredie ohňa, čiže vlastne sa neuhasí a pokračuje ďalej horení. Ďalší kandidát bolo voda. A ten vlastne rozhorí oheň, lebo pridáva kyslík. Neskôr bola CO2, a to je posledné štádium horenia, ktoré uhasí oheň. A posledný kandidát bol bután, ktorý je vysoko horľavý.
So, which gas would you like to see another experiment? Okay, so the right answer was butane. So let's continue with butane. Thank you for your attention, and let's invite another group.
So, hello everybody. My name is Teresa. Hi, my name is Hannah. And this is our helper, Maddie. As you already saw, butane is flammable, but it's also 2 times heavier than air. So we will use these 2 abilities in our experiment. So we will use this massive metal trough and we'll pour butane in it. And on the other side will be kettle and it will flow and you will see what will happen.
Pre tých, ktorí nerozumeli, tak vlastne bután je plyn, ktorý má väčšiu hustotu ako kyslík a preto nestúpa hore, ale klesá ku dnu. A v tomto pokuse sme ho vlastne liali po odporite a pri kontakte s ohňom splanul, pretože je vysoko horľavý.
That was pretty cool, right? So we have another experiment with butane that will show you Alex and Patrick.
Alright, I'm here again. You know what's funny? I wasn't even supposed to be on this Erasmus, and I'm doing the most work. No, I'm just joking, okay?
So, Patrick, have you ever imagined becoming a magician?
Of course. I mean, it was my dream. Since a very young age, I always thought of like magicians as being cool, but you know, I never got the chance to be one or to even try what a magician could feel.
So that's really cool because we have one way so you can become a magician.
All right.
Firstly, you need to put your hands in the bucket with water.
Right. Not with this though.
No.
All right.
Probably not.
Okay. Should I take my watch off?
Yeah, it will be cool because like maybe it can burn a little bit.
Oh, okay. I'm excited though. Oh, I forgot the protection thing. I mean, who needs it, right? I guess I do. All right. Can you still hear me? Hopefully you can.
And then you will take this really flammable foam.
Okay. Just smell it first. Right. I'm really scared. Oh my God. Well, I'm not a Christian, but I think I'll become one. Oh no. Okay, another mistake, doesn't matter, it happens. Tension's crazy. Oh my God.
Wow!
Oh.
I think it's really cool.
Yeah, but... Well, sorry.
Vážení návštěvníci, věnujte prosím pozornost tomuto hlášení. Prosíme maminku nebo babičku Amálky, aby se dostavili na recepci. Opakuji, prosíme maminku nebo babičku Amálky, aby se dostavili na recepci. Děkujeme.
Amalka is lost, I guess. Okay, so what if we created like this chain of people, and they would like...
Maybe some our colleagues will like to join.
Okay, yeah, Matla Ratka, come in. All right. Yeah, we all need protection. What? Are you all nervous? We should like do the ritual. Okay, no. More. Oh, yeah. Wake. Oh. Can you smell that? Those are my hairs.
So basically, what's the point of this chemical? Because it's a reaction. We added to the foam combustible gas, which is methane. Even though it's very flammable, our hands practically didn't burn. Even our nails are done and great. So it's because water makes a protective layer or molecule, we can say. So our hands and everything stays intact. A ešte môžem po slovensky, tak je to vlastne preto, že keď pridáme do toho saponátu s vodou, ktorý nám vytvorí penu bután, ktorý aj keď je jeden z najhorľavejších plynov, tak voda nám vytvára nejakú protektívnu vrstvu, ktorá chráni naše ruky a nespali nám ani ruky, ani chlpy trošku, ale nechty máme tiež v pohode, takže tak.
Ladies, come on in.
Hello? Oh, can you? Right, so we know that chemistry has mastered the art of constantly surprising us. That's why it's chemistry, right? But what you will see here now is something that you would expect like a little bit less. Because we can make a gel, like texture, that can burn. Sounds pretty weird, so let's ask Terka how to do it.
Okay, can you hold?
I will.
Thank you. Here we have two glasses with liquids, as you can see. In this first one is water with calcium acetate and few drops of sodium hydroxide, and in the second one is ethanol with few drops of phenolphthalein. So now I will pour it in this third glass.
Wow.
That was cool, right?
Yeah.
So now, as I hope, yeah. Oh, it's pink gel. Like, I love it. Pink is my favorite color.
Yeah, mine too.
Of course. So why is it pink? It's pink because sodium hydroxide is alkaline and phenolphthalein turns pink when there is alkaline, so it turns pink. But why is it gel?
Right, so calcium acetate that is present in this weird mixture that we see is very well soluble in water, which means that it dissolves quickly in water. But on the contrary, it is not as well dissolvable in ethanol. So when we combine those two together, instead of getting like a liquid, like a nice flowy liquid that were the two previously, we get this like weird mushy, right, pinkish thing. So that means the ethanol is still present in there. And we know that ethanol can burn.
Yeah.
So,
Can you please turn off the lights?
can you please turn off the lights and Terka bring on the fire?
Oh yes.
Right, there we have it. So, now we can see that the ethanol really stayed there. But what you see burning is not the gel itself, it's actually the vapors coming from the ethanol.
Já ještě to tady rychle vysvětlím. V češtině tady to je směs octanu vápenatého, vody, etanolu, phenolphthaleinu a hydroxidu sodného. Ten gel je růžový, protože se phenolphthalein zbarvil do růžova vzhledem k přítomnosti hydroxidu sodného. Na gel se to změnilo, protože octan vápenatý se dobře rozpouští ve vodě, ale špatně v etanolu, proto vznikla takováto směs a hoří to kvůli přítomnosti etanolu, který se vypařuje. Takže to, co právě vidíme, je vypařování plynu z etanolu.
But even though I love pink, right, it's still one color, and I feel like chemistry can do more than that. It's a bit lame, to be honest. So why don't we invite over Kaya and Nelka, who can demonstrate a wider range of colors.
Thanks. For sure, you'll see much more colors in our permanganate chameleon experiment. Here we have a solution of water, sugar, and a few drops of sodium hydroxide, which provides the alkaline environment. You can pour it there. And here we have permanganate. So, Mel, what do you think will happen after we mix those?
I think it would turn to purple.
You can try and we'll see.
Wow, that's amazing. How is it possible?
Maybe mix it. Yeah. That's because in sugar is glucose, which acts as a reducing agent, and the permanganate reduced, and because of that it changed color.
Takže po slovensky v tomto pokuse sme zmiešali manganisten s glukózou v zasaditom prostredí. A vlastne cukor redukuje manganisten a preto sa vlastne mení farba roztoku, presne ako kamerón.
In the next experiment, you'll see another color for chameleon by Maggie and Latka.
It's me again. Hi. So we've seen some impressive color changing, but we will stay at the change of colors a little while longer. In this next experiment, they will appear, disappear, change, sometimes when you expect it and sometimes when you absolutely don't. My colleague here, Radia, say hi. Hi. She's from Slovakia, and she's going to show you another one of her tricks. But before that, I have to tell you that you get to play an important role in this experiment as well. Because as the colors will change, you can guess what the next color is going to be. And don't afraid to shout it, argue, be confident, because to be a chemist, it requires confidence, even though the chemist will prove you wrong sometimes. So I'll leave it to Radia, and we're starting with water.
Yeah, we start with only water. And what do you think if I put this water to an empty glass? Nothing, right? Yeah.
Surprising?
And what do you think now if I put this water into this empty glass?
Nothing again, right?
No.
Wrong.
It's pink. Magic. Yeah, and now, what do you think?
Red.
Red.
What? Red.
No, it's colorless. And the next one, what colors? Go ahead.
Black. Black?
Green.
Green.
It's like blue.
Color?
It's blue. It's
blue, yeah.
It's blue. It is turning a bit blue, yeah. Nothing is wrong, technically.
Yeah, and what do you think now? Oh.
Nothing.
Nothing?
No. Really pretty. No. And now?
Nothing.
Fire.
Purple.
Ah.
Turning darker.
And now what do you think?
Black.
Black.
No. And now?
Turning darker.
Red.
Great. Pretty cool, huh? So, I mean, it did seem like magic, but can you tell us the secret behind it?
No, takže ako ste mohli pochopiť, tie kadičky neboli prázdne a na spodku každej bol pár kvapiek nejakého roztoku alebo nejakých kryštálikov a vlastne tým sme menili pH tej kvapaliny, ktorú tu máme a tým vlastne to menilo farbu. Že tam boli nejaké indikátory a ako ste mohli vidieť, kamelo.
Great, thank you. So the clock is ticking, we're nearing to the end, but with another experiment, other two gentlemen are coming with their Yodin clock, which you will see in a moment. I invite Vasek and Philip to the stage.
Alright everyone. Who here like experiment where absolutely nothing happens?
And then suddenly, boom, everything changes?
If so, then you're gonna love this. Ladies and gentlemen, this is the iodine clock reaction.
This experiment has better timing than most alarm clocks.
So, this is solution A. It looks innocent. Water, starch, potassium iodine, little acid, and sodium thiosulfate.
And this is solution B, hydrogen peroxide.
So, what do you think will happen when we mix them? A, nothing.
B, explosion.
Or C, chemistry magic.
Alright, let's have a look. Oh, there it is.
Ladies and gentlemen, iodine appears.
So, what happened?
Firstly, potassium iodide provided iodide atoms and hydrogen peroxide slowly converts them into iodine. But we also added sodium thiosulfate, which converts iodine back to iodide. So firstly, nothing really happens. But after all the sodium thiosulfate is used up, the iodine starts to build up and reacts with starch. And that's what created this dark color, I would say. The timing depends on concentration. More hydrogen peroxide, acid, or potassium iodine makes the reaction faster, but more sodium thiosulfate delays the color change. That's why it's called iodine clock reaction.
A v češtině při smíchání roztoku peroxid vodíku oxiduje jodové ionty a přetváří je na elementární jod. Zároveň je tam ale přítomen thiosíran sodný, který ten jod redukuje zpátky. Takže nejprve se tam hromadí jod, ale potom, co ale vždycky ho thiosíran redukuje zpátky. Ale když se thiosíran vyčerpá, tak se tam jod nahromadí tak, že vytvoří tento jodoškrobový tmavý komplex. A všechno závisí na koncentraci látek ve směsi. Čím více je tam kyseliny, peroxidu vodíku nebo jodu, tím je reakce rychlejší, ale čím více je tam thiosíranu sodného, tím je reakce pomalejší a tím delší je ta prodleva předtím, než se změní barva roztoku.
This experiment is safe, visual and satisfying.
So remember,
chemistry isn't just equation,
it's about timing. Thank you.
Thank you. After us, there are the last experiment after us. And there are two of my colleagues, Matej and Maroš, and they are going to show you a rocket, but not from NASA.
So, what you are about to see now may look like magic, but it is actually a science experiment based on physics and chemistry.
This experiment called alcohol rocket, it shows how chemistry energy can quick transform into motion, sound and pressure.
The main principle behind this experiment is combustion. When alcohol vapor mixes with air and ignites, a large amount of energy is released in a very short time.
This rapid release of energy creates a sudden increase of pressure which pushes the rocket forward.
This effect follows Newton's third law. Every action has an equal and opposite reaction.
Are you ready to start to count with us?
So I'll just pour the rest of ethanol out and we are ready to start.
So let's start count.
So 5, 4, 3, 2, 1. So as you could see, science can be exciting, powerful, and sometimes also a little bit dramatic.
This experiment shows how simple physical and chemical experiment can be impressive.
So this was our last experiment, and now we can just all say goodbye to you all. So come here, Evan. Thank you for watching and for your attention.
We hope you enjoy all of your demonstration and have a nice day.
Goodbye.
Chcela pripraviť niečo v angličtine, ale to už povedali oni, tak chcem sa poďakovať hlavne kolegyňke Alene Šafrovej, ktorá je nekonečná studnica nápadov a experimentov. Náš prvý Erasmus projekt dopadol podľa mňa výborne. Toto bola krásna bodka na konci tohto projektu. A chcela by som sa poďakovať Ikre Landii, že sme tu mohli zdieľať tieto priestory a že naši študenti si mohli vyskúšať, samozrejme aj vaši, vyskúšať byť na chvíľu vedcami a snáď niektorých uchvátime a budú nasledovať kroky kolegynky alebo možno naše. A ďakujeme všetkým rodičom a všetkým súčasným, že sme sa mohli takémuto niečomu zúčastniť aj za študentov. Ďakujem.